right, hello everyone. This is a project I finished a while ago, but I'm getting around to recording it now. I took a look at narcotics as provided by the DEA, United States Drug Enforcement Administration. On their website, dea.gov/fact sheets, you have different fact sheets that contain information on all these different narcotics, drug use. Let's look at, I don't know, let's pick a random one. Fentanyl, that's in the news, and it takes out a lot of people. So on each page, you have general information, aliases, street names, effects on the body, overdose effects, how things are consumed, etc. You download a fact sheet, it will give you a PDF with all this information. This one's in Spanish, but you gotta search all the websites and check them for your English versions. So for this analysis, believe it or not, the federal government doesn't love when you web scrape them. So I had to do this one by hand. I got every single PDF of every narcotic that was available by the DEA, and I aggregated that information into a flat file CSV. Let's see, I'm trying to see how I did this. So yeah, looks like I started with the DEA, and I just took the name of the narcotic, its classification, stimulant, depressant, designer drug, hallucinogens, its drug scheduling. That's a level of, I guess, how many years you'll go to jail if you get caught with it in the United States. Aliases, separated by commas and spaces. Methods of abuse, separated by commas and spaces. Is it ingested? Is it injected? Is it smoked? Etc. The effects on the body or mind, and the overdose effects on the body or mind. These were all similar categories across all the DEA fact sheets that I was provided. Once I had those, I separated this into a fact table of just my narcotics, stimulants, their drug scheduling classification, and their methods of abuse. Everything else I treated as a dimension. So the aliases, amphetamines, several different names. That's going to be a one-to-many relationship, right? Effects, one-to-many relationship. Overdose effects, similarly, one-to-many relationship. So I tried to use that star schema as my data model to create this localized database on narcotics. So next I'll show you my process of creating and uploading the database for this. I took that fact Excel sheet, made it its own CSV. Then I took the dimensions, the alias dimensions. What are the street names? The effects, the overdose effects. And from those flat file CSVs, I uploaded them into my database. So let's make this page small here. Used a Python script here, SQL Alchemy. I use SQL Alchemy or SQLite for a lot of my Python to SQL just uploads. Uploading a CSV in SQL is a process if you do it by hand. Pandas, that's how you interact with data frames. And OS is just operating system. It'd be the same as if I opened the command prompt in Windows. First, you have an engine here. You connect to your database. You enter PostgreSQL plus PyScope PG2. That's got to be part of the code. Postgres, here I would put my password, the host name, it's something like 12.5.0, whatever it is, and your port number, I think mine was 4 numbers, slash Postgres. That's the name of my database that I host locally. I use the OS here to change directories to just that file folder that I want. And then I use pandas to read the CSVs. They all had special encodings. Don't know why. Usually it's just UTF-8. But once I figured that out, I use the pandas to SQL function. I connected to my engine, which is right here, that localized database. And if it already existed, I would append. So that means I'm adding to the database if it exists, not replacing it. That's a risky move, but I suppose if I have something new, I can make sure it gets included, and I can always clean the database in SQL itself by deleting duplicates. No indexes on these, no zeros, one, two, threes. And I had a schema called DEA. A schema is like a subsection you can have inside a database. So, interesting. 165 files got uploaded in the last one. It's just reading the last thing I did, which would be the overdose effects. So, 165 rows got uploaded. My apologies. Here, oh, and this is where I created the data model. Yes. So create table if not exists, name, varchar, alias varchar, and then, yeah, I'm using the DEA database here. So it looks like I dropped that schema idea and just created a database itself. Here I'm adding my constraints. So here's a foreign key that links the alias dimension to the alias dimension in the fact table, or the foreign key is the name. So yeah, names are always going to be the same. I did that again for effects of your narcotic. Did that again for the overdose effects of your narcotic. Yeah, I run an SQL query here where I basically interjoined every single table to see, I don't know how many rows you have once everything's connected. So I can open up my database here. Here you see DEA. You may not see that. I've got dimension alias, dimension effects, dim overdose effects, and fact drug. So if I select everything from my DEA database, the dimension alias, you can see it got uploaded. Amphetamines, aka bennies, aka black beauties, aka crank, etc. And I'll post that query I wrote previously, where I interjoin every single table. So I'm getting 23, almost 24,000 rows when you include every single permutation of the effects, the overdose effects, and the, what else is the dimension here? The alias names. As you can see, if you just interjoin every single table, the name is going to repeat itself several times. A better query would probably not include the names, but because I have such a small data set, it's not costing me too much computational power, 14 milliseconds. So I can see amphetamines here, stimulants. They're ingested or injected. They're Schedule 2. Yeah, they're labeled Schedule 2 by the Department of Drug Enforcement. And here are some aliases. So uppers, speed, etc. Obviously, this is a bad query. So let me just do something simple. Let me do aliases as A. I'm pulling from the fact table, where name equals cocaine. Everyone knows about cocaine. I run that query here, hey, name is ambiguous. Right, because I have a name from my fact table and a name from my dimension table. So where f.name is cocaine. So here I just join cocaine fact to the alias table by joining the names. But cocaine, stimulants, schedule 2, here's the abuse methods. Smoked, snorted, injected, smoked, got it. And then I have the name again and aliases. So blow, coca, coke, crack, flake, snow, and soda cot. This is a private, what is it called? Database I created for my local machine. And as you can see, I still need more filtering. I wrote this out as a sentence, right? Comma, space, and soda cot. So when I separated things by commas, looks like I still left some things in, like the ands, etc. This isn't the best SQL query either. If you were trying to be efficient when writing a query, you would only keep the columns you desire. So here I want the fact table name. Say I want the fact table classification. Say I didn't care about drug scheduling. I just wanted to know the aliases. So let's go. If I run that query, you're just going to get 3 columns. There we go. Cocaine, stimulant, blow, coca, coke, crack, etc. Yeah. So I ran this as a educational project and also just an informative project. You know, you look in the news, you see the fentanyl crisis, you see all these different things. And as a data analyst, I'm all about the facts, right? Okay, what are the overdose effects? What are the effects of this drug on a particular individual? I want to make it very clear that I'm not an advocate of drug use, but I know a lot of people struggle with addiction in this country. And it's advised that you do projects that have meaning to you. So it's kind of taking that empathetic angle, trying to create this. Thought it was an interesting project. Might be a little controversial, you know, drugs and all that. But again, from a purely educational standpoint, I thought this was a decent project for building a data model and practice with SQL. So thanks for looking at my project, and catch you on the next one.